My name is Irina Vipac-Barbar, and I'll be moderating today's webinar about the climate neutral and smart cities. Before starting the event, I would like to introduce some housekeeping rules. So you should know that the event will be recorded, and the recording as well as slides will be made available afterwards. We are using Zoom in a meeting mode, so please stay muted and keep your video off during the presentation. You can post your questions in the chat or also in the Q&A. In the discussion session, you will have the possibility to raise your hand or raise questions live, so please use the hand raise function in order to do that. And let me at this point give some background information to the work that we will be presenting today. So the work itself was done under the EOSC Future project. And the EOSC Future worked on establishing a trusted platform with open and fair data, resources and services for all scientific disciplines. The platform integrated existing data and services from science communities, research infrastructures, and e-infrastructures. Via a single sign-on system, European researchers have access to interoperable resources and support to manage the full life cycle of their data. So EOSC Future supported EU research by bringing different new opportunities for European researchers. And this was done through different paths. I'll not go too deep into that since we have a long program in front of us. To demonstrate the EOSC value through cross-domain research, 10 science projects have been organized. The objective was to move beyond the topic-specific centers and to consider cross-domain interdisciplinary research. This has helped to grow EOSC by linking research communities and science disciplines, preventing the creation of silos, defragmentation communities, and supporting the open science. In this list, we see the project that took place in the EOSC Future project, and one of them, the 9th one, we will present today on climate neutral and smart cities. And most of these projects were done in collaboration with different science clusters, which we'll also say something about now shortly. So in this webinar, as said, today we will be presenting the work done in the Science Project and Climate Neutral and Smart Cities project. I will be joined today, today's webinar by colleagues, David Reiner, then also Arfan Gregory, Benjamin Boster, and Hilda Ort. And for today's agenda, just to quickly say, we'll be saying something short about the objectives, but then we'll go into depth about the methods and results of the project itself. We'll be presenting the prototype tool, something about the utility, fairness, and metadata, and also we would like to look forward into what are possibilities to do similar research in the future. There should be enough time for the panel discussions with questions and answers. So the main objective of the science project was to demonstrate the environmental data and data about people's attitude, behavior, and involvement so that this could be combined for social, political, and scientific analysis. So in this project, the scientists from two large clusters, namely SHOC, which stands for Social Science and Humanities Open Cloud, and then ENRI, which is an environmental research infrastructure. So these scientists work together with the aim to producing new and useful outputs for the benefits of research community. So one of the main questions that we set and we wanted to actually have an answer to is we wanted to find out whether climate and air quality that actually affects the responses in social science surveys. And for these, we set a set of objectives for that, what we wanted to do. So the topic was European urban citizen attitudes and values in context of climate and air quality, and then integration of data from different research domains. This is also really important. And then what also was on the table was collaboration between professionals from different disciplines, because this is also one of the rare cases. We usually still work in silos, but we try to put different elements on the table. As mentioned, the data and scientists from different domains joined in this project, and I think something more about that will be said further on by my colleagues, so I'll leave it to them to do that. So now let's try to dive into background and methods of the project itself. And I would like to ask my colleagues, David Reiner from Swedish National Data Services and Hilda Orton from the Norwegian Agency of Shared Services in Education and Research to tell us a bit more. So please, colleagues, go ahead.
Next slide, please. Next slide, please. Yes, so what is the research question here? Does personal experience of climate and environmental extremes influence attitudes to environmental issues? In theory, yes, because exposure to climate-related extremes may make impacts seem more certain and more immediate and more likely to affect the person themselves. Next slide, please. So can social scientists measure this? Yeah, you may ask that again. We can ask about facts, for example, about addresses, where people live, where you live, you know that. About your occupation, you know that. But when asking about things like, are you affected by air pollution and something like you need to bring in an evaluation, and in this, is this reliable, or is that the only thing that we really use to answer about these things? Anyway, there are many questions. So like Whitmarsh kind of shows here, the question about climate change, is that something that frightens me? It kind of has a kind of correspondence with if people are affected by air pollution, and it shows really a very significant difference here. But the measure used for air pollution experience is the respondents' own evaluation of health impacts from air pollution. So, direct experience of perception bias. Well, in this project, we try to do it a little differently. We don't use only respondents' evaluations, but we try to take measures from the environment to kind of measure these effects. And so the next question, can social scientists and natural scientists work together to measure with this? And this is exactly what we have been doing. We have, from the social science side, we have the European Social Survey headquarters. We have the Swedish National Data Service from the social science side. Also ADP here, social scientists, and SICT. Also Benjamin and myself. And from the kind of natural science side, we have David here, who has been of super help in this project. We have had Anne-Marie, Hannah Clark from IAGOS. We have had also the Norwegian Meteorological Institute and Nidlund, the Norwegian Air Quality Institute, to help us with this. So what we actually have been doing is to combine interview or survey data about respondents' attitudes and beliefs with independent meteorological or environmental monitoring data, for example, air quality. And we also tagged every survey response with environmental conditions for the respondent's location. So on the regional level, that was. So this is basically what we have been doing and who have contributed. And next slide, please. So the data sources we used for this, we started with the European Social Survey data. This was basically an initiative from the European Social Survey and the SESTA, the consortium of European social science data archives, to do something about this. And in 2016, the ESS fielded a questionnaire module about attitudes to climate change and energy use, and that was a kind of basis for the work. And working together with David and others, we thought about which kind of data sources we could use really to integrate together with data from the ESS. And we found then data from the EEA, or European Environmental Agency for Air Quality, and then for Copernicus ERA 5 for climate or meteorological data. And the EEA data, they are based on measurement stations that are located around, in particular in cities. And also the ERA 5 data, they are gridy data from little squares all everywhere around. Next slide, please. So what is the ESS? It is a biennial social survey. It's really covering many of the European countries. It has been around since 2002, so over 20 years. It captures attitudes, beliefs, and behaviors. It has some questions that are repeated every time, and some rotating module. And one of the modules in 2016 was about climate. And in the project, we used data from the ESS from 2016 through 2023 for 10 bigger European city regions. And they are included in the combined data file. And in the integrated file, all ESS variables are kept. Next slide, please. So here are some of the ESS questions related to climate change in 2016. So they are about if the respondents think the world's climate is changing, how much the person has thought about this before, the cause of climate change, responsibility to reduce it, how worried you are, and also how you think the impact of climate change will be across the world. Next slide, please. So this is basically the 10-city region we have been covering: Stockholm, Oslo, London, Brussels, Berlin, Prague, Vienna, Budapest, Paris, and Madrid. And then we are going more over to the natural science stuff, and I hand over to you, David, please.
Thank you. Yes, David Rayner from the Swedish National Data Service. So I'm going to talk a little bit about the data processing we use to get the air pollution and meteorological data to tag the survey results. So start with the air pollution data from the European Environmental Agency. And when we went to decide what we were going to do, we had a couple of criteria. So first obvious one is we needed to be able to get data from 2016 and onwards, because this is where the climate module came in. And we also only wanted to use data sources where the data was very fair, as it were, preferably an application program interface that we could actually write code to go and get the data, so that if we wanted to redo this next year for next year's ESS data, it was just a matter of rerunning it rather than someone having to go and download files, etc. Which is one of the main reasons that we went for this EEA air pollution station data. Now, very quickly on air pollution, as the most important air pollutants for human health are particulate matter, two size categories, 10 micron and 2.5 micron, so-called PM10, 2.5, nitrous oxide, which is mainly from cars, sulfur dioxide, not such a big issue now from unfiltered coal burning, and ozone, which is a secondary air pollutant. So it forms in the atmosphere from nitrogen dioxide. So often in big cities, you have lots of nitrogen pollution. And then in the countryside around, you have lots of ozone pollution, which has been created by chemical reactions. So this is what's measured. And the question is, okay, how do we condense this into some index of air pollution that we can then use to tag results? So if you take the next slide, well, the European Air Quality Index has already been designed to do this. It's a composite index, which basically tries to give a qualitative estimate of air pollution based on all those measurements. It's basically what's the worst of them in terms of human health. And I have a snapshot here from the European Environment Agency's website a couple of days ago when I made this slide. You can see it's bad air pollution across the North Sea under the Baltic there. And if you look at this and you wonder, why are those countries so bad air pollution? And I think it's worth giving a little bit of background to here. So if you take the next slide, okay, just leave it there for a sec. So on the left side is the air pollution monitored at the stations. On the right side is simulation, the situation 3 days beforehand. Now, 3 days before I took this, it was sunny across Central Europe, and sunshine is lovely in spring, but this is where you get a big pulse of air pollution from particulate matter, from all the soot and dust which sticks to the wet surfaces in winter from the roads and burning things. And then the sun comes out and it blows up in a great big cloud. And then if you click the simulation, you can see what happens to this cloud in the 3 days afterwards. It basically blows around the continent. And hopefully at the end of this, it didn't catch at the end of the slide, but at the end of the slide, it does look pretty much like what was measured. So, so air pollution is not just what's emitted, what the pollution sources are. There's a lot of transport involved. Okay, next slide. Right, so we had this example, Vienna. There are, I think, 11 stations there where they're monitored, and they're overlaid here on the the population density. And you can see some of the stations are where there's a lot of people. Some of the stations are where there's not so many people. But, this outer polygon, the nuts polygon, is the precision of the geographic information. We know that the respondent was somewhere in this region. So we need to take out get some measure that is representative of all the respondents in the region. And in this case, we just took the average, we took the value representative of all stations. So in fact, the worst air pollution value for all stations. If you take the next slide. And you can see here, I don't know if you can see my cursor, Irina, do you see the cursor? No, okay, I'll just talk then. Sometimes that's a good approximation, sometimes that's a bad approximation. So if the air pollution is mainly coming from outside, like on the 29th of December there, all the station values, this is all the time series plot of those stations, they all up until halfway through the graph, they all go very, very quickly. And then you get a different climate situation and the air pollution varies all through the city. And that enormous spike there is January the 1st, which presumably is the fireworks on New Year's Eve. Okay, take the next slide. So Air Quality Index is a great index because it summarizes all the pollutants, but it has some issues. The first one is there's no historical European Air Quality Index data. So we had to recalculate it ourselves from the station data. Bigger problem is that it was never designed to be used to represent an extended period of time. We haven't talked about this yet, but we don't expect that it's the air pollution on the day. If air pollution affects people's attitudes and responses, we don't necessarily expect that it's just on the day itself that it's important. It's presumably some time window beforehand. So we want some way to average this. And there is no decided way to average the air quality index because it's the worst. And if you take the worst over 300 days, well, you always get the worst. It'll always be extremely poor. And really, there's no way to average this sort of thing anyway. Like, it's qualitative: good, fair, moderate, poor. How do you take an average of that? Okay, take the next slide then. Right. The other source of data we wanted was meteorological data. And here I've got is a bit more easy to get a handle on. So we use data from the European Centre for Medium Range Weather Forecasts Reanalysis database, which is always summarized as ERA5. And this is a fantastic data set. It combines observed data and model data. So you get a spatially complete data set, every location, every hour, with 31 kilometer resolution. So it's for gridded data. And the data we used was temperature at 2 meter height, which is the standard meteorological measuring height, total precipitation in millimeters of water, and wind gust as measured at 10 meter, which is also, so these are simulated to match what is actually observed. Okay, take the next slide there. To try and give you a bit of a feel for what this data set looks like, I took a snapshot of the Copernicus Climate Pulse website. And on the right-hand side there, you can see a map made with the ERA5 temperature data set. And this gives you a bit of a feel for the resolution. It shows the variation across the continent really well, but it doesn't go down to the detail of climate variations within a city or coastline effects. It has the sea effect, but not like the sea breeze that you get in the real world. Those are just a bit too fine detailed. So that's the sort of level of detail you get. The right-hand side, just as a matter of interest, is the global average surface air temperature, which on the date I took this, 11th of March, was the highest ever recorded in the time series, which actually goes for nearly all of last year. So this, I guess, is why we're doing this. Okay, keep going. Right, so this graph shows how the overlay of the ERA5 data then matches with our response region. So the squarish grids show the ERA5, the temperature data set, and then the dots are the population. And in this case, we decided we would weight the data. So basically the weighting factor, which is the pinkish color for each grid, is a combination of how much of the polygon is within the grid cell and what's the population density. So basically everything outside is 0, regardless of what the population is. So you can see that the central region counts for 44% of the weight here. Because what we end up with is a single representative temperature for the whole region, because we don't know where the respondents lived in this region. Okay, keep going. Right, so the basic idea so we got some data. We've got air pollution data, we've got meteorological data. Now, what are we going to tag their responses were? And the theory here is that an extended period of anomalous weather is probably required to increase environmental concern. This is from a paper. But as events become more distant in the past, impact recedes. So we don't know what time window to target. So we chose several. Basically, we characterize the regional conditions for the 7 days before each interview, the 30 days, the 90 days, and then the 365 days before each interview. And for air pollution, that was slightly different, but similar. Okay, keep going. And then these are the types of indices we created and that you can get for every response. What was the worst air quality on the day of the interview? What was the worst PM2.5 for the date of the interview? But then because you can't average that, we need to take a slightly different statistic to go back in time. So then we took the number of days with poor air quality or worse during the week before the interview and the month before the interview. Okay, so take the next slide then. And then for the meteorological data, it's a little bit easier. It's just what's the temperature on the day of the interview, the maximum temperature, and then what's the average for the week leading up to the interview, the month before the interview, the 3 months of the interview. And then there's some supplementary data as well of different types, like what's the calendar average for that time of year, like over the 1991 to 2000 base period. So, and what's the anomaly? So depending on whether you're trying to compare responses between different cities or whether you're just looking at one particular city, you might choose a different climate there. Okay.
Thank you. I think that's a really nice intro for everyone to know what kind of data we had used and what kind of elements we had in the back. I would like to invite everyone to pose their questions in the Q&A sessions, and we'll be replying to them later on. But now I would like to invite our another speaker, Benjamin Boyster, to tell us about the provenance. So please.
Yes, hello everybody. So I work at the data archive where we are at SICT, where we archive and create the data from the European Social Survey. And when we archive the data, we have to be fair. So in the context of fair, the data has to be described using a metadata standard. So our question was here, how can we describe the data integration process and also the variable computation that David just presented to us? And there are different standards that can do that. And for the data file and variables, you can, for example, use DDI codebook or DDI lifecycle that are standard from the Data and Documentation Initiative. And right now, they're developing a new standard called CDI, cross-domain integration. And this standard is now under review and will be released in course of that year. And the good thing about that standard is that it has a process model. And the classes from that model can be used in order to describe the computation processes that we have used in this process, in this project. On that slide, you can see the subset that we selected from the model. The good thing is that this process model is rather small, and we just selected a couple of classes. And here we are just about 10 classes, but it's enough and sufficient to describe the entire integration process in quite a detailed way. Next slide. Yes, here's just a screenshot from the model. The activity is one class from that model. It can be used to describe a process. You can see in the yellow box the attributes of this class. Then there are some relationships to other subclasses like the step or the control logic. Okay, next slide, please. Yeah, and the structure of our metadata that we applied to the process is hierarchical. We have a nested structure. We have, for example, a top activity. Then we have sub-activities. And then we have steps to further describe our activities. On the next slide, we have entered some context. So the purpose of this process is to integrate the climate data and air quality data with data from the ESS. And we have sub-activities, one to describe data processing for error 5, second one for EEA. And then we have steps. Steps are used to describe the variable and indicator production in a very detailed way. Okay, next slide. So the question was now how to generate the metadata. Since we are using a brand new standard, there are no tools available to do that. So the first thing, can you see on the next slide? We just entered all this information, collected them in tables. And each table refers to one class in this process model from the CDI. And then I was writing a little script that produces a valid format or XML format in this standard. And then we built a tool on top of this model and this model output. And this will be presented now in a little live presentation. To do that, I just share my screen. Just a second. So now we are on the web page from the European Social Survey, and there's this under data. There's a subpage called ESS Labs, and I think I need to. And when you scroll down here, there's a little description about the project. We have some publication research papers that you also can download here, and then we have this link to the prototype. This is one that we have developed under the project. And it looks a bit like the model. So what you see here, it's that we have a hierarchical structure. So we have a top level class or element. Just click on it. And it just tells you that here we describe how to integrate climate and air quality data with ESS data. And we've done that for a couple of cities like Berlin, Oslo, Stockholm, and so on. And the next step is the different data sources that we have described. The first one is the error 5 data from Copernicus. If you click on that, you get to the next page where we describe how we can ingest and prepare data from error 5. So the main input is just the website, because first you have to know what is error 5. So if you click on that, you get routed to the web page, and there's an overview and also a page about API description, how you can download the data, and which kind of data you would like to download, the different topics like temperature, wind, snow, all these important and interesting data sources. And then we have sub-activities. And there are 3 sub-activities that we entered here. First one is how to get the raw input, then the marshalling data, and finally the data processing. Let's start with the raw input. So here we describe how we did the ingest for the raw input for error 5, and we have different inputs that we also just learned about in the previous presentation from David. Again, there's this error 5 homepage, and then we have the nuts polygons, and we have different level of nuts polygons, like level 1, 2, and 3. And it depends on what kind of data we have available from the European Social Survey. But let's just click on one of these to show you how it looks like. That are typical polygons that you can use in. Now it comes back. So it's a huge data file. But these are the polygons, and you can work with that with maps or with different tools. So some of you might have worked with this kind of data. This is input. And then the output of these elements are net CDF4 files. And all together, when we call the public API, our experiment results in 12,000 different data files. So that's really huge, because it's starting from 1990 up to 2022. So to run this public API that takes several days, maybe weeks, just to collect the data. Okay, then we move on to the data marshalling, because nobody or no researcher would like to work with 12,000 data files. Then you really need to have good computers, and you need to know how to process NetCDF files. So we did the data marshalling at the next step. So the input again are 12,000 different data files. And then we got also this global human settlement layer. So also, I think David showed that as well. It's from Eurostat information, and you can download the data here. So if you would like to reproduce this, everything can be reproduced by clicking the links or running the documentation and scripts that are available. And the output is an interim data file. It is quite a huge data file. It can also be downloaded from our data portal, but it's a really huge Parquet data file. So that's why we did a third step. It's a data processing activity. And in this activity, we are producing an integratable data file that is released on the ESS data portal. In addition to that, we have now a new class that's called the step. And this class explains how the different variables or indicators have been produced. I just start with this one, create this variable, and click on that. It tells you that how you can compute the target variable TMPT CMX. This variable, I think it has a label, temperature in degrees Celsius. It's a maximum at a specific date. And this had 4 input variables. So this variable is based on a different temperature variable, on the regional units, the population, and on the date of the interview. So by looking at this documentation, you can follow the process, how it has been produced. And to run it yourself, we also entered the link to the script, how it was produced. Now, this here is just a text shell with a description, but the actual code was done in Python. And by clicking on the script, you get routed to a GitLab repository. No, it's a GitHub repository, actually. And in this Python code, the cell is highlighted where this variable has been produced. So it's quite useful for the people or for data scientists to can work with pandas and Python. So it's quite nice. It's freely available for download here. All files are available in a repository. Okay, in addition to that, you can also click on the final variable and look how it and check how it looks like in the data portal from the European Social Survey. I do that now. So now you get routed to the final data. So let's see, the question is about a temperature degrees Celsius date maximum. And for the regions that are here we have the mean. You can see, for example, Madrid has the highest mean and also has the lowest mean. So I think that makes sense. I just return to the tool and I go to the last part here in the documentation process. The last part is the merging of the data files. So the climate data and the air quality data was finally merged with the survey data, and only the dates and are here present in the data files of when the interview takes place for the different respondents. I click here for the integration for ESS round 8. It was the round with this climate module. And you also can click on the final entity that is the final data file that has been produced and made available for everybody to download. So it's free for download. You just have to log in. This data file consists of many variable groups. Here in the prefix, you can see that are ESS variables. So like for example, well-being, click on how happy are you, and then you get the result for the different regions that participated here in the data. And then you can see, oh, now we get to air quality, temperature, and precipitation, wind gusts, and so on to the other topics, to the data that have been integrated. Okay, let's just conclude with an example from the air quality. So here, let's say, David talked about number of days with poor air quality, maybe the week before the date of interview. I just click on that. See what happens here. So what we can do now, we add data from the survey, from the European Social Survey, just to see how it connects. Maybe we use a question about climate change. So, for example, do you think one was good? Do you think climate change, the world's climate is changing? And then you can just look, for example, here, this is the data for Vienna. I think I can have a full screen here, just to see how I can look at it. Here, the category, the people who answered is definitely changing. Also might have a higher mean than the people who are saying it's not changing. It depends. It can be, cannot be. So that's something that we can now try to figure out. Are there some correlations? So it's a nice way just to browse the data and to see are there any connections between climate, air quality, and questions from the survey data. Okay, right now I think I stop sharing and we continue with the next presentation.
Thank you. Let me go back to my screen sharing. Benjamin, thank you for your presentation. I think we got some impression of what could be done with the data and how good the tool is in the back, but I would like to also invite David to say something more about how things could be used.
Okay, I just take 5 minutes to try and give some impression of what, if you use this data, what you have to think about and the choices you might make. So we had Eric Harrison did a initial modeling use case looking at the question of, well, how does temperature affect people's attitudes about climate change? And he said the data set has its limitations, but hints at a multitude of analytical opportunities. And a little study he did suggest that for each degree increase in temperature in the calendar month of the interview, there is a 7% rise in the likelihood of the respondent reporting that they worry about climate change, which was not quite statistically significant, but it shows the sort of questions that you might answer. So I thought for our little use case, I'll just take another question. Does recent precipitation affect happiness? Are people more or less happy if it's rained? You got the next slide. So we have had the question in the European Social Survey, how happy are you? And respondents are surprisingly happy. I thought that most people on the scale of 0 to 10, most people are around 8, except in Prague for some reason. It's the only place where the median goes down to 7. But somewhere around 8 is where most respondents are. And then, okay, so now we want to see how does this vary according to whether it's rained or not? And then there's a couple of things to ask. The first is, what variables will we even use? What are we interested in looking for? Is it the week before? Is it on the day, the week before, the month before? And then there's also the question that, how are we going to, if we're going to do a study across regions, how are we going to normalize the result, as it were? Because some regions obviously have a lot more precipitation than others. And there's no right or wrong answer to this. You really have to just decide what you're going to try it, which is not very good when it comes to assessing statistical significance, but there's no other way of going forward. So for this study, I decided I was going to take total precipitation for the month leading up to the interview. So that's a good value. But then to normalize it, there's no monthly average for the time leading up to the interview. So I'd have to try and normalize it by the calendar month, the average for the calendar month. I think I've got that one on the wrong spot. It should be the one below, but that's okay. So it's not exactly right, but it's going to be pretty good. So just to give you an idea, precipitation the month before the interview, it varies quite a lot across the cities, but it also varies for different respondents. So nearly all of these studies are done in not in the summer. I think there's one city where they're done in summer. So some respondents have responded where there's basically been no precipitation. These are our violin plots. It's like a histogram turned on its side. So where it's a thicker line, is more respondents had that amount of precipitation. So for Prague, there's a big difference. Some respondents like less than 20 millimeters in the month up to when they responded to the interview, some up over 180. Okay. But then there's the question, what are you actually going to do with this data to ask? So what's your hypothesis? Is it that if there's a lot of precipitation, people will be more unhappy? Is it that if it's very low precipitation, people will be more happy? You actually need to construct a mathematical hypothesis that you can test. And even this can be difficult, because you might say, well, what about when there's been twice as much precipitation as normal? And then you find, well, half of the cities, no one had twice as much precipitation as normal. So you can't use that as a criteria. So in this case, I chose to compare two different samples for each city. And on the left-hand side of each of these density graphs is where the respondents had less than 50% of the normal precipitation for the month. So left-hand side is where it's been dry, and the right-hand side is 25% or more precipitation than normal. And then the top is the statistical significance. And so I found two cities where there appears to be a difference, London and Budapest. And it's both in the case that people are slightly happier if it's been dry than if it's been wet. Now, you can think of a number of other situations too. So if we look over at Stockholm, not statistically significant, but actually people are less happy if it's been dry. And this might have to do with the Swedish, there's no bad weather, there's only bad clothes. But it could also be that Stockholm's cold. So when there's precipitation, there's probably snow. And maybe people are happier when it's snow than when it's just ice and gravel on the roads. So even when you've got a good hypothesis, you need to think what your results have been. Okay, I hope you had fun with that. I had fun doing it.
Thank you. I see there's a lot of things that could be done in these data, and if there are some researchers and also students that would like to play with that, I think they could have a really fun in their classes as they would go. So let's move to our next speaker. So I would like to invite colleague Arfan Gregory to tell us something about the fairness and metadata. How did we tackle that in the project? Arfan, please.
Thanks, Irena. So David was having fun, and now I'm going to talk about something that's not so much fun, which is fair, and talk a little bit about metadata. I'm changing gears a little bit here because you've seen a lot of the sort of data and the metadata and how we're dealing with that from Benjamin's presentation. I want to put this in a little bit more of a frame. So I'm going to talk about what we're trying to achieve with FAIR overall, and what it requires, and then what we learned in the project from that perspective, because the word FAIR has come up a couple times, but I'd like to dig into that a little bit. Next slide, please. I like to remind people that FAIR is about better research. For decades, we all happily worked away in our silos and didn't share a lot of data, didn't share a lot of resources, and didn't have reusable services and so on. And in the past 10 years, that's changed in a very radical way. And I think it's important to think about why that is. FAIR as a phenomenon has come about, I would argue, because the kinds of problems that we're dealing with as globally, as societies, are very threatening. Things like climate change. And that's why I think this project is particularly interesting. And the problem that we face is that climate change is incredibly complicated. And if we're going to give access to data to the researchers in a practical way, we have to do that in a cross-domain way, in a multidisciplinary kind of way. And that's what this project was really exploring at a practical level. I like to remind people that even though FAIR is about making life easier for researchers, that's an important thing, but it's not the end goal, because the point of that research is to support policy. Now, David's example about happiness and rainfall may not have major policy implications, but when you consider the more serious questions you could ask about social attitudes and climate change and the kinds of policies that governments are able to implement in response to climate change, then you begin to understand that this is actually a pretty serious challenge and a serious kind of data integration that could have a lot of utility in the real world. Now, this project was an example of one of this kind of data integration that we need a lot more of. But I think that when we think about FAIR, we can understand that that these kinds of data integrations in the face of these complex cross-domain challenges are pretty important, and that we have to think about how practically we can do this and make things like unfamiliar climate and environment data comprehensible to social researchers. Next slide, please. I'm sure I'm not the first person to say this, but when we talk about FAIR, we're really talking about good metadata. And when I say metadata, I am not referring only to a handful of discovery fields that people assign to data files, which is a very typical way to approach FAIR. I'm talking about much richer metadata, similar to what Benjamin was showing you, where you have information about your variables, about how they're structured and measured, what they mean, and that you have information also about the provenance. And all of that metadata needs to be in a granular form, in a machine actionable form, and very importantly, in a standard form. In cross-domain scenarios, what we found in this project was that you needed more metadata, not less. Because when data is unfamiliar, you don't just need the standard information about the variables and how they're measured and what's there to use in the way that David was discussing. You also need to understand the context. Where did this data come from? How is it processed? Can I trust it? And there's a lot of information, I think, that is sometimes missing because a provenance metadata is not typically published alongside the data. And yet it is very important if we want to be able to reuse the data in a good way. If we look at the data that we worked with in this project, you'd see that there are a lot of standards, which are important in FAIR, like the DDI standards for social science, for climate data, that's NetCDF and so on. But domain standards like that actually aren't that useful in a cross-domain scenario. Don't ask a social scientist to deal with NetCDF. That's not something they're familiar with. That's not something they understand how to work with typically. And so there are some real barriers here, even though NetCDF and DDI are considered FAIR standards within their domains. So there were some real challenges here in terms of the metadata and the standards and the fairness. Next slide, please. This is really the last slide on this topic here. What we learned in this project was that the metadata was there for all the data sets. There was actually a lot of documentation and information at Copernicus, at the European Environment Agency, certainly at the ESS, which I think has an excellent metadata system based on DDI. But in practical terms, navigating that complexity, it was far more than you could ask a normal researcher to do. A social scientist would have to spend weeks digging through the Copernicus data to understand how that reanalysis data was put together. Where did it come from? What were the methods? And so on. And a lot of that information is buried in PDFs. It's not accessible in standards or in an open standard maybe, but not accessible in standards that social scientists understand particularly. And the presentation of the information was lacking. Very, very hard to navigate. What Benjamin showed you was our answer to that, which is that if you have that standard provenance information and processing information, you can build a presentation that combines all these things in an easy way for the researcher. But it was a lot of work to do that. There is no single cross-domain FAIR standard for describing provenance. PROV is a very good standard. It's widely used, but it's implemented in different ways. You have things like the common workflow language. You have the DDI-CDI standard that we used, and there are others. But there isn't consensus right now on a good FAIR standard for provenance or process. And that's a problem in terms of fairness. Another thing that we learned was that the paradigm for presenting provenance information to researchers doesn't really exist. There are some examples out there of other provenance browsers similar to what we built. There's one in public health that we looked at. There's a federal agency in the US that has done this for some high-value economic data sets, but none of them actually provide the information in an open standard way, and FAIR demands that. So we found ourselves in a situation where we had to choose an open standard and then design the sort of UI paradigm that Benjamin showed you, which I think is a great piece of work, but there wasn't a lot to build on. And this was a little bit of a challenge because this is high value metadata, but it's not metadata that's typically provided. So those were sort of the takeaways from this project in terms of fairness and how we had to interact with the metadata. I'm going to switch gears here now because we're changing topics. I guess the next slide, Irena.
Yes, as you said, so let's see, as you told us now, it was quite a bit of a challenge to actually dig all the information, but let's see about our look forward, what we can do in the future.
Yeah, so I'm going to talk a little bit here about EOSC broadly, because I think EOSC is a typical kind of open science cloud. And probably it's the most active one that I'm aware of, but you have the Global Open Science Cloud, the African Open Science Platform, there's one in Canada. There are a lot of these kinds of national and regional open science clouds coming into existence, but they all are trying to do basically the same thing, which is allowing an efficient reuse of resources and services for their communities. The idea here is that basically any researcher should be able to go and get any resource, data, metadata, services from any domain and use them easily. Now, that's a very ambitious goal. And I really wanted to give a little bit of an impression of where we are as EOSC here, because the EOSC Future was obviously looking forward and trying to identify what the issues would be for the next round of projects. And I think this project was very valuable in that regard. I would say about EOSC that there's an awareness of the importance of metadata standards, and that's emerged very clearly. You may be familiar with the EOSC interoperability framework, which is maybe the best example of that in EOSC, but this idea that FAIR demands standards and that interoperability demands standards has come home, I think, in a good way in EOSC. And so we are seeing a pretty interesting work in that area. There are a lot of services that have been developed. Nope, back please. Irena? Yeah, thank you. There are a lot of services that have been developed, and that's some of them are quite useful. Some of them, like the ones that support the EOSC interoperability framework, like the schema registry, the mappings registry, are really good. And those kinds of technical challenges have been, I think, quite well addressed. One that hasn't been as well addressed, perhaps, are aspects of legal and organizational interoperability that are being explored a little bit now. But I think in terms of EOSC, the technical challenges have been easier to address than some of the less technical ones, because we understand the problems better. Next slide, please. What we learned in this project was that there are some very different levels that you have to operate on if you're actually going to perform cross-domain research effectively. I think you've gotten the impression from Hilda and David's presentation and from Benjamin's presentation that there really are different facets to this problem. And I would break it out like this. First, you have this idea of the scientific collaboration. How do we study the problem? What data do we need? And once you have those sort of questions answered, you have to look at the data and metadata systems. How do we access the data and use it? What information do we need to use it? What metadata? How do the different systems integrate? How can they work together? At the end of the day, though, you also have this idea of organizational and legal interoperability, and very often the scientific and system requirements are pretty much the same, but the organizational mandate can be very different. And there's a different set of issues there. All these different levels are interrelated, and I want to spend just a minute talking about each one of these and then talk about how they are related. Next slide, please. I'm going to make some general comments here. I think we're going to have a panel, and Hilda was really the person here who coordinated this work. So she might be a better person to ask if you have questions about this. But my impression was that it wasn't that hard to engage the scientists from the different domains. You have to get the right experts, right? Obviously. And you can tell from David's presentation, there's a lot of nuance here. But scientists are by their nature intellectually curious, and they tend to get easily engaged because they're curious. Our problem wasn't engaging the scientists so much as getting their time, because the priorities they have from their institutions weren't necessarily aligned with what we were trying to do in this project. So we had a really good experience working with the scientists, I think, but working with their organizations was more problematic. And ultimately, I guess it's because this wasn't a quote normal project, that this kind of cross-domain collaboration, it felt a little bit like it was a one-off, if you will, that this wasn't a normal kind of research. And yet, when we think about the EOSC big picture, this kind of cross-domain project should be normal, right? And so I think there's some tension there. But the scientific collaboration overall, I thought was really very positive. Next slide, please. You can guess what I'm going to say about the systems integration. The data sources were available and usable. You saw that. Benjamin showed you how we did it. The metadata existed, and sometimes in standard form, usually in standard form. But for cross-domain purposes, it wasn't really fair because the domain standards weren't necessarily useful in the social science community that we were trying to serve. So there was some tension there, and it was a lot of work to prepare that data and to write the code to do it, to be honest. And maybe in an ideal FAIR scenario, an ideal EOSC scenario, that would have been much easier. We learned absolutely that there needs to be better provenance and process metadata. That was the biggest takeaway here, no question. And you saw how much emphasis we placed on that. The presentation of that, I think, is a really important input to EOSC. That kind of browser where you can go seamlessly from the processing information, from the source, through the integration, and then to the description of the variables that you can use in your own research. I think that kind of presentation is really valuable. And we did it for this project, but a similar thing could be built for other kinds of integrations. And I think that's important. it was very clear that we need better cross-domain standards. The EOSC interoperability framework talks about how to navigate that space. There are things like the World Fair cross-domain interoperability framework that's beginning to recommend specific standards for specific purposes. There's work in Fair Impact and other places. But there is really a clear need looking ahead for establishing agreed cross-domain metadata standards so that it's easy to take the data coming from another domain and integrate it with data in your own domain. And that was a big challenge here. And it really raises the bar for what this kind of data interoperability looks like at the systems level. But I think these were good lessons, and I think that this will provide a lot of input to further work within EOSC. Next slide, please. And then we get to the organizational and legal collaboration. I'm going to talk about these separately. I would say as legal collaborations go, this wasn't too bad. The data is all public and free. ESS was commercial, does not allow commercial use, but the other data sets do. So you end up going with the most restrictive licensing for the integrated data set. That ended up not being a problem for the ESS community of users. We didn't have a lot of questions about legal liability or confidentiality. I think there was some discussion of intellectual property, which comes up, and that's a little complicated. But in general, the legal picture here wasn't too bad. Now, this had to be navigated in a very manual way, I would say. There isn't really any way to easily determine the licensing considerations or how they combine. And that's potentially an issue for EOSC broadly, if you really want to be able to easily reuse data. And that's an area there's going to have to be a lot more work on. The organizational collaboration was a little different because infrastructures expect to serve their user communities, and those communities are made up of researchers. In this scenario, we were looking at the European Social Survey interacting with Copernicus and the European Environment Agency. Those are infrastructures. We had to make, what was it, 20,000 or 12,000 different web services calls to pull down one data set. That's not what a normal researcher would do, but the ESS wasn't a normal researcher. We were an infrastructure, and these infrastructures don't expect their users to be other infrastructures. The alignment, the collaboration is difficult because these infrastructures didn't anticipate that this would ever be something they'd have to handle. And yet, in an EOSC case, this communication between the infrastructures is going to be critical. So I think we really have to think harder about, are these larger players serving large amounts of data able to work together in a collaborative way? Obviously, we have the technology to do it, but we haven't done it today. And it's going to be a lot of work. And how do we prioritize which of these collaborations are really valuable, right? And that has to be driven by the research questions. And I don't have a good answer for how we prioritize which infrastructure should work together. But it is, I think, pretty clear that EOSC is a place where we could begin to discuss how best to approach these issues. You know, which infrastructures serve which research communities? There are lots of questions here that surface. Last slide, please. The trick to this, though, is that all of these different levels I'm talking about are interdependent. I think it's fair to say that at the end of the day, the science has to come first, that scientific collaboration is the key to the whole thing. When you put the scientists together and they start looking at the right data and the right methods to address a research question, that's where your requirements come from for what your data and metadata systems have to do, for what services are going to be needed. And ultimately, that would drive things like the prioritization of how infrastructures collaborate, right? So the science has to come first at the end of the day. That's the whole point here. It's interesting when you look at the provenance example, particularly, because we emphasize provenance in this project because it was necessary to make the data usable. But it had some very interesting impacts at other levels of the collaboration. One of the things it did was provide transparency. When you think about legal issues and issues about organizational interoperability, one of the concerns there is whether people get credit for the data they produce and whether their data is being reused responsibly by another infrastructure. When you have really detailed provenance information, you have a very high level of transparency. If you think back to the COVID epidemic and some of the legal issues that came up around the absence of provenance for some of the data sets that were being used, there was a lot of legal fighting. If you had a good provenance chain that showed where that data came from and how it had been processed, those would have been non-issues at a legal level and an organizational level. And that kind of transparency also promotes trust. Researchers are more willing to use data they have confidence in. They understand what they're working with, they know where it came from, and they know that those sources can be trusted, and they can see what you did to it and analyze that. And that kind of provenance has a knock-on effect legally and in terms of the researchers' willingness to use the data in ways that aren't strictly at this metadata systems level, right? So you can see these levels sort of interact. Ideally, they would all be working together, but we have to figure out how best to do that. This project actually was used as an example in a launch meeting last Friday. I wasn't at the meeting. It was for the Oscar bid in EOSC that they're just starting now. But it was very interesting. I watched the video, and it seemed like the commission was emphasizing the scientific impact of proposals. And my impression was that they were doing that because they really want people to focus on the science and not just on building cool services or doing cool technical work. And I think that's the right way that they should be thinking about this. But I'm not sure that's going to be enough. I think within EOSC, we really need to look at these different levels of collaboration, see what they require, and see, make sure that they are being addressed directly, that the issues that surface in projects like climate neutral and smart cities are being taken on board and being thought about, being dealt with in a proactive way. And so I think this project is a really interesting one when you look at the future of EOSC. I was at the EOSC Winter School in Thessaloniki in January. There was a huge amount of discussion about organizational and legal interoperability, about some of these other levels that weren't just the systems working together with the data and metadata. And I think there's a lot of promise in EOSC that people are thinking hard about these issues. And I think EOSC gives us an opportunity to address them in a really good way. I think it's on us to take that opportunity and to come up with solutions that will work. So I'm going to stop with that. I thought this was a brilliant project for highlighting some of these issues. And I'm hoping that as we move forward in EOSC, we'll actually be getting to address some of them and realize solutions. Back to you, Irena.
Yeah, thank you, Arfan. You pointed out some really good elements here, and I will now go back to go further to the Q&A. I would like to address some questions that came in at the registration time, and then give also other people that are attending this webinar some time to put their questions if they have something in the Q&A. So one element that I would like perhaps to ask, and Arfan, I think you already started some of these in your topics, is so there was a question that came in and how best to promote interdisciplinary research. I think that what you had said is that we had challenges for institution to work, but it's also the point that actually, when researchers publish their work, they usually publish in their discipline. So do we see now with EOSC and all the projects that were done there that interdisciplinary publications are also coming out? Do we see that as a plus or a minus? Is this a new level of science? I know, Arfan, if you want to start, but then also others, if they want to comment.
I'd like to hear what Hilda has to say about this. All I would say is that I think this is not just an organizational issue. I think Irene, I think it has a lot to do with the scientific collaboration. I don't know, Hilda, if you would have a good answer here.
Yes, I think so. And yeah, we have, I must say, in the end, we have had an excellent collaboration across domains, and many thanks to SND and David to be super, and we couldn't do it without you, and also with the ANRE partners that come in eventually, and and so on. Hannah Clark from EOSC, and also people from the Norwegian Meteorological Institute and NILU, who worked free for us. And when it comes to how to do this, well, we can have to continue the collaboration if possible. That is of course a way to promote it. And we have been writing some papers, and I think it has been much viewed. For example, the methods paper we wrote together about the background and methods that Dave and I presented in the beginning, and also the other papers from the project, Benjamin's about the workflow, and Arafon's about reuse and reproducibility, and so on. So that's one way. It's out there, it's open, and so on. What we can do is to try to get together again and collaborate where possible. And then we need to have access to people's time, and also funding is very important. And EOSC Future has been a kind of good project that way, that it opened up for this type of research, and that it was funded also. We had the opportunities to have some of these months to work together. And now out of that collaboration, both the ESS will, for example, have in the ESS conference in the summer, they will have a session about interdisciplinary things, and I will organize together with some of the ENRI people that I got to know through EOSC Future a session in at the EGU, European Geoscience Union conference in Vienna, a session, and we got 37 abstracts. So there will be two sessions with talks in that. So there are ways that we just try to do the most of it. What's happening now is that this is done very much on the research at the researcher level. So we ask Dave, for example, if he would have the chance to come. We ask Irina, we ask these other colleagues from ENRI that we met. We also need some organizational support, both from the level of EOSC and also from our own organizations, to be able to do this. Because as you saw from David's presentations, and also we are all very motivated to continue this, and we think it's very important. So we are looking for help, and we do our best to try to follow up.
I think it is fair to say, Hilda, that I mean, what I've seen in the last round of Horizon funding is that there's explicit mention of doing cross-domain examples. So I think that there's some demand from the funders for this. Like you say, I don't know if the organizations have taken that to heart yet, but I think there is some pressure on to sort of do more cross-domain research. That's my sense of it, just judging from the recent round of Horizon calls.
Yeah, Arfan, I totally agree with you. This is also what I had seen out there, but as we thought today, yeah, it's still a bit challenging to see, how people will connect, how different domains will connect, and also, as you had mentioned, a lot of information might be out there, but it's not necessarily structured. It's not necessarily machine actionable, and this is something that we really noticed that would need to be done in the future. And Hilda, as you had mentioned, it's a money issue. As Benjamin told us, how many hours it needed only to kind of gather all the data in the back. It's not something that you can do in the afternoon. So it's really something that needs to be thought in advance. And if we are creating this kind of workflows and collecting this kind of data, there needs to be some support in the back. And while we're talking about the support, there was a question that came from one of the registrants. Is how do we think that libraries can help in this work? Anyone wants to take this forward?
From our point of view, I guess we have a network, and many of our the contact people at the universities in the S&D network are actually librarians. And one thing which they can really work with is helping researchers, when they publish data, to publish useful metadata and useful documentation. We have people sometimes enthusiastically want to share their data and make it fair, but then they need a lot of help to get going. So I think this is definitely one place where other librarians across Europe probably are doing the same thing as what we're getting the librarians to do in Sweden is get their knowledge in how to help publishing data the same way they can help researchers choosing journals and writing abstracts and that type of thing.
A question for you, David, about that comment. There's been a lot of emphasis, I know in the Netherlands, for instance, around data stewardship on projects, and that there should be a funding within a project structure to have a data steward. And very often that ends up being the data librarians at the university. Is there anything like that in Sweden? Are you seeing a similar discussion around data stewardship as an activity at the research level, or is that not there yet?
We're seeing a lot of discussion.
Okay.
But the problem is that there's not scope within a single project to employ a data steward who has subject-specific expertise. There's not people to employ anyway, even if you have the money.
Yeah.
So we need structures where we have these people who serve a much wider community than just the funding of a research project. I think this is really something that needs to be taken up.
Yeah. No, that's very much what I've seen in other places in Europe as well. Interesting.
Yeah, Arfan, just to add, in Slovenia, we just started last year a huge national project where we are building a data stewardship network. And there's going to be around 20 or plus new data stewards employed in coming years. But yeah, I think it's, even if you have a support, as Dave, you said, it's a lot of knowledge on a specific subdiscipline that would need to be there. But I think they might at least try to help when we are talking about findability, how to access, that they might have some knowledge on how to publish the results and the data that came out, but it is what we had seen from colleagues commenting, there's not much new money coming in for open science. So projects are expected to produce open science results. They are expected to publish results openly, but there's not additional money for that. And we all know that it does cost to prepare things, as we had seen it today, that it has a really good documentation, so that it could be reused. Yeah, thank you for that comments. Perhaps just something to address further on, what kind of plans do we have for updating these tools regularly? The tool will be available on ESS page, if I understood correctly, but perhaps something on that could be said. Benjamin or Hilde?
Yes, I think I can answer this question. From the ESS website, there is now quite a nice link and description of the project where you get routed to the data portal. We can download the data, and from there you also find this provenance tool. The data itself will not be updated because it would require some funding to get new data. But we are also now working on a new. We are looking forward to a new project that we just submitted a proposal for. It's called So Green, and for that project we also might do something similar, like integrating data with climate data with ESS data or the data from other social infrastructures. So we will continue working on that topic.
Yeah, thank you. I think a lot of projects are now looking into trying to link or to combine different items, so instruments. I think the work that was done here might really benefit them all. Perhaps just a last element to add to that, and then I'll ask Hilde for you to wrap it up. I was just thinking, you know, if one would want to create another index, how easy would it be using the tool that we have currently now?
I see. Yeah, I can, David can correct me, but as I see it, we have some of the data that we have available in these large Packer files that Benjamin was talking about earlier. They contain more or less close to the raw data that we downloaded. And they are on an hourly basis, and it's huge file. But if you would like to, for example, for air quality, if you would like not to only use the European air quality index, if you would like to use the world index, that is a little stricter about what is good air quality, for example. Then you can use these data, and you can look in the tool about how we did it for the European air quality index and do something similar, for example. So that is one way, but you have to use the more detailed data in order to do the best indicators. I don't know, Dave, if you have something to add there.
No, I think that's a good point. So it would depend on what exactly someone wanted to do. So for example, if a new index simply meant you wanted to choose a different time period, we want like 14 days instead of 30 days, then yeah, it would be a couple of changes to the code and then rerun it and you'd get the answer. Whereas if someone said, well, I'm interested in, oh, I don't know, some other pollutant, which we're not even measuring, or they want to filter out different types of air quality monitoring stations and only take those in the center of the city, then that's going to be a bit more complicated, I think. So it would very much depend on what someone wanted to do. Small changes shouldn't be too hard, as long as you're happy to take down that big data set and clone the GitHub repository and get in there.
Yeah, thank you. I think also what I really like in this project is that we really did a lot of detailed documentation, you know, how certain elements were actually calculated, so that, as you had said, now if some others want to repeat, they can easily see where something could be changed and they could repeat it. Yeah. So thank you. Hilde, perhaps if you want to close the session of today, we are almost at the end.
Okay, so next slide, please. Yeah, first, here you can see the list of contributors who worked with us here, and some of you are here today. That is Dave and Iris, also from SND. The collaboration with SND has been excellent. Thank you so much. And then you have Arafan, who also, together with Achim Vakarov, helped as consultants. Achim Vakarov developed the provenance to that Benjamin showed. Then you have, of course, Eric Harrison from ESS HQ, who kind of was one of the initiator of the whole thing, and also wrote that paper with some of the results. And then a bunch of people from SICT, including myself and Erik Stavestrand. He worked on the Python code, and together with Dave helped him with that. And Benjamin worked on the workflow, XML, and the tool with Achim, and then other people. Also, our old boss, Knut Schork, he also was very keen to initiate that before he retired. And then you have also from IAGOS, Hannah Clark, who came in as an author of our methods paper at the end, and I continued the collaboration with her in relation to to EGU and other things. And of course, thank you very much, Irina, also who have helped also regarding not only with this webinar, but also with the methods paper and the kind of legal and organizational interoperability stuff that really came in a little late on us in this project. The project has been doing a great job, but I'm happy now that for example, other projects like Fair Impact, where Anne-Sophie Fink is responsible for a module about interoperability, is now focusing more on this. So that needs, as our fund said, some more work. So thank you very much for all of this, Irina. And then also the expert from NILU and Meteorological Institute. They did a great job. They were excited and they wanted to work with us freely, really, to help a little with how to calculate the different measures. So that was very nice help. And also I would like to thank Alex, who is helping here with the webinar from EOSC Future, and the whole project team has been really helpful, and also the work package 6 lead. Thank you very much. And it gave us a really good possibility to work together that we are very happy for. And I'm very happy with the outcome of everything and the new connections we build. And I hope we can continue to work together in some projects in the future also. So thanks to that. And the next slide here is a little, where can you find the project deliverables? We have been talking a lot about the deliverables, but not where to find them. First, we have the EOSC portal, that is how it looks now. And there a page called ESS Labs, where all the deliverables are linked up. It's added at the service in the market page. Then EOSC Future has a web page, and I think Alex is about to update that with new stuff. And I hope also that the video and presentation from this webinar will end up there. And then you have the ESS Labs page where all project deliverables can be found and linked up. And there is a link to where you can find the data in the ESS data portal that Benjamin showed, and also a link to the provenance tool. Next slide, please. And here is just to point out our papers. So the way you can find them. There's method papers about all the things we were talking about today, like one more project-oriented paper about the project as it is, one background and methods paper where David and I and Eirik Stavestad and Iris, Irena, Achim and Hannah Clark contributed. And then a workflow paper by Benjamin mainly, reuse and reproducibility paper by Orofan, and Eric Harrison's kind of a scientific paper about this. So that was all from us. And unless you have some questions in the end, I would like to thank you, every one of you, for your contributions, for attending the webinar, and for helping out with this project from all of us. So that is from me. And thank you.
Thank you all. See you on next occasion. Follow EOSC Future website and all the elements that we'll produce in the future. Thank you.